Good morning, my dear friends. Welcome back to my YouTube channel. Today I am going to solve a Leetcode problem on March 11th. The problem is number of substrings containing all three characters. The problem is number of substrings that containing all the three characters. What are those three characters? Let us see problem statement. Given a string S which consists only a characters A, B, C. Given a string of S only containing A, B, C. Now, we should return the number of substrings containing at least one occurrence of all these characters A, B, C. We should return the number of substrings. We should return the number of substrings containing at least one occurrence of all the characters. That means in a substring, for a substring, when do we count it is a substring is it contains at least one occurrence of A, B, C. If there are at least one occurrence of A, B, C, then it is called a substring. Let us see brute force to solve this problem. What would be the brute force? Here they have said that we should count number of substrings. First of all, we count number of substrings. Let us take an example A, B, C, A, B, C. Brute force approach. First, we initialize I and we initialize J. For every increment of J, we count the number of substrings. Substrings would be this, this, this. And next substring would be this. Next substring would be this. Next substring would be this. And many more substrings are possible. That is, we are using nested loops. We are using nested loops for finding out the number of substrings. It would be lead to O of n square time complexity. Time complexity is O of n square, which is high complexity. So, what is the optimal approach? Let's see example. First, we understand example. What this example is? Example is A, B, C, A, B, C. Let us consider this substring. This consists of A, B, C. It consists of all the occurrence of A, B, C. So, the possible is A, B, C. And coming to the next, we consider this substring A, B, C, A. It consists of two number of A's. We can have any number of A's, any number of B's, any number of C's. But we should consist at least one occurrence of A, B, C characters. Next, we can consider A, B, C, A, B. A, B, C, A, B. Next, coming to the next, we consider BCA. This would be the next substring. BCA. Next, it consists all the number of one occurrence of ABC. Coming to the next, we can add ABC, BC. Next, BCA, CAB. Next substring is CAB. Next substring is CAB. Next substring is, we can concatenate this C here, CABC. Here, we should note one point. Here, after observing these substrings, we get an idea that if there is one occurrence of ABC, then we can add any number of letters. We can concatenate any number of letters We can concatenate any number of letters here. It is also a result. It will be also a result plus one result. It will also include in the result. So here we see that it is an substrings. They have asked if we should count number of substrings. Number of substrings. Substrings of size. It will be of size k size. It will be of size k size. K size is dynamic. That means it is not fixed. It is dynamic. K size substring. We get one idea that we can use sliding window. Sliding window on before 2 or 3 days, I think the same problem on the same concept. If you see these three problems, you can get stronger in the sliding window concept. I have already discussed how the sliding window approach and all in the 8th March problem. You can see there, it is a sliding window problem without fixed size. It is a problem of without fixed size. Without fixed size. So this is the problem. Now let us see how can we solve this using sliding window. Using sliding, first they have said to count the number of occurrences. Count the occurrences. Count occurrences. To count the occurrences, we can use hash maps, which keep track of the hash maps. It keeps track of the characters and index values or count of the values. Hash map consists of key value pair, character, integer. It is key, it is value. Hash map to keep count of the occurrences. Step 1. Next, for sliding window, we initialize left is equal to 0 and right is equal to 0. Result is equal to 0. Result is equal to 0. Now let's see. Here the window size. Here there will be two conditions in sliding window. Until we get window size. Until we get window condition. We get window condition. What we have to do? Condition. Until we get window condition, we should increment the right value. That means we should get the all occurrences of the, suppose A, B, C, D, E, A with a substring of S. Until we get, it is left, it will be pointed right. Until we get the window condition, that means the condition is all occurrences should contain all occurrences of A, B, C. To count the all occurrences of A, B, C, we use hash map. Until we get all occurrences of A, B, C, we increment the right position. Now, coming to the next point, if we get window size, what is the condition? Then we increment left to plus plus. Means we should concise the left and right. We should constrain the left and right. We should constrain the left and right to the window size. Here, by adding these elements, if we get the window size and at the left, if the left element is containing in the substring, if left element substrings, left element is giving count or it is correct substring, we decrement if we exclude the left element. If we exclude the left element, we decrement value of the decrement value in hash map. We decrement value in the hash map. If exclude, if hash map doesn't contains the value, hash map does not contains the value, does not contains or contains count as count is equal to 1. Then if hash map contains count is equal to 1, then we remove the key. Key. Remove the key. These are the conditions. These are the conditions. Initial in the earlier classes, I have discussed how to build the intuition for the sliding window and the condition how it would be up to the K window size, what we have to do, and after K window size, what we have to do. These are the conditions. Now let us see an example problem. Let the example be A, B, C. A, B, C. We keep a hash map of type character integer. First, we initialize left to 0, right to 0. Result is equal to 0. Result is equal to 0. First, we check whether A is present in the hash map. If it is not present, we keep the element or the character at the particular index of right and we keep default value as 1. Next, we increment right. It is not present. B is not present. So we keep the into the hash map. Let HP be the hash map. Next element R. We increment the right to next element. That is C comma 1. Here the condition is achieved. That means all the characters have occurred at least once. All the characters have occurred at least once. That means it would be the substring. It would be the substring A, B, C. This is the substring. Here we have seen that if we add any number of letters to the substring, it is also a substring. If we add any number of letters, then it is also a substring. How we add? How can we add? That means we can add using result. We can add using if we add subs s dot length s dot length minus the right means all the elements are included from s dot length to right element. All the elements are included. We can include these elements also into this substring. So the substring would be 1, 2, 3, 4. Result is equal to result plus. Here the condition is equal to result plus equal to of s dot length minus right. This is the condition. We increment the result up to the, if we have attained the substring length, we can add the result value. Result would be 4. Incremented. That is here. For this condition, we get 4 number of substrings. Now, here we have attained the substring length of 3. That is condition is true. Now we increment left. We increment the left. Suppose the left will point to here. Suppose left point to here. Now right is this. BC. Here A will be removed. From the hash set. Now coming to this, it doesn't satisfy the condition. That is only B and C are in the subset or substring. So we increment right. It is not present in the hash map. So we include this into the hash map. That is A1. here condition is true. That means all the substrings are present. Substring contains A, B, C. So the condition is true, and we increment the result value. The possible substring is B, C, A. We can increment these also into the substring. These also into the substring. So the possible substrings are, it is BCA is one substring, BCAB is another substring, BCABC is another substring. So we increment 3. Now coming to the next point, coming to the next, here we attain the window size. We attain the window size. Here we attain the window size. So we increment the left to here. We increment left to here. The hash map removes B. Hash map removes B comma 1. Now A hash map contains A comma C. Now we increment right value. We increment right value. Hash map contains B comma 1. We put the into the hash map. Hash map contains CAB. CAB. Hash map contains CAB. It is the possible substring. That means the condition is true. The possible substring is CAB. It is, these are the possible substrings. One, this is the possible substring. This is the another possible substring, and this is the another possible substring. The possible substring is C. Let's denote this using this CAB. CAB is a substring. For this substring, we can include one, this, and this also can be included. CAB is one substring, CABC is another substring. That is, here we get another two as substring. Another substring is here. After this, the hash map condition is true, and we have attained the maximum window size. So we increment the left. That means considering this hash, this set. The possible substring is A, B, C. This is 1. Now, right value is incremented to here. We have attained right is less than n. So the condition is false. After incrementing the right, the condition is false. The number of possible substrings are 4, 3, 2, 1. That is 10 substrings. Let us see whether this correct is the correct answer. Yes, it is the correct answer. I think the sliding window, how the brute force approach for this is brute force approach and the optimal solution. Here in the optimal solution, we go iterate through only once. So the time complexity is O of n. O of n. How I think this brute force and the optimal solution for this is clear to all. So let us see code for this problem. Let me keep this board aside. Now we declare hash map of type character comma integer, which is used to keep track of the count character comma integer of SP is equal to new hash map. This is the initialization of the hash map. Now we keep left is equal to 0. Now we keep left is equal to 0 and int of answer is equal to 0. We initialize left and answer or result. Now we increment. Now we keep answer is equal to 0. Right is equal to 0. Right is less than. We increment right until the value is less than or equal to n. Right plus plus. Initially we calculate the character at the right position. We calculate the character at the right position. That is equal to S plus character of right. effect of height. If it is not present in the hash map, hp dot put of chr, comma hp dot get or default. And yesterday I have discussed about what is the operation get or default. Chr comma 0. If it is not present, it will keep count as 0. If it is present, it increments the value to +1. hp dot. Now, while if we have if we have attained the window size of 3, if it is size double equal to 3, now we calculate the left value. We calculate the left value. What is present in the, we see what is present in the left, of left, caret of left. Now we increment the answer. If we have attained the size of 3, now we increase the answer. That is, answer is equal to s dot length minus right. S dot length minus right. Now, after calculating the complete array, now we increment. We have attained the window size. We increase left value. Here, if hp dot get of left double equal to 0, caret of chl, hp dot put dot chl comma hp dot get of chl minus 1. We decrement the CHL in the hash map. That means the left element, left pointer element, we decrement this value. Now hp dot get of left. If it is 0, then we remove the element. Remove CHL. We increment here. We increment left plus plus until we attain the size of 3. We increase the left. After this, we return answer. Here not left, here it should be CHL. Now let us run the problem. I hope this will be accepted. Yes, it is accepted. Thank you, my dear friends. Subscribe to my YouTube channel. If you find this problem is easier than the sliding window approach using the two approaches, using fixed length, and it is not unfixed length, that is dynamic length. So thank you, my dear friends. Share with your friends. Let's meet on the next day. Thank you.